Sorry? No, he's remote. Okay, it's 9:30 here in London. Um, about time to start the IPPM session, first session of the week. So welcome everyone. If you're not here for the IPPM session, then please check which room you want to be in. Tommy is here as well. He's joining us from California. Must be a nice time of the day there.
It's dark and rainy, so we are celebrating traditional winter England weather here.
All right. So this is an IETF session, so you should familiarize yourself with this Note Well slide. You will probably be seeing it quite a lot during the week. But basically, everything you say here is a contribution to the IETF, and that comes with a set of considerations. So if you're aware of patents and things like this, you should familiarize yourself with the guidelines and rules around that. It's also important to note that things here will be recorded and can be made publicly available online. So you're aware of this. And please kind of maintain a respectful tone to each other when having discussions and disagreements. And there are a lot of documents you can read if you want to further familiarize yourself with any of these matters. Right. Also, for people who are on site, remember that we have a masking policy here. So you need to wear masks in all meeting rooms, and it's also recommended that you do that in the common areas, but not required. You may briefly remove your masks if you're eating and drinking, but that cannot be an excuse for leaving them off for longer periods. So please try to kind of respect these rules. It's for all of our safety. Of course, if you're actively speaking, meaning that you are up by the microphone presenting, it is okay to take off your mask while you are presenting, but that's pretty much the only exception. There are no exemptions for mask wearing, no medical or otherwise, so please be aware of that. And also be aware that the masks that are required should be equivalent to N95 or FFP2 or better. And there are free masks all around here, so please, if you don't have masks, go fetch some. Right. A bit of meeting management. We're running this through Meet Echo. You have the link here. Queuing for everyone, including on-site, is based on Meet Echo. So if you are here, please join the Meet Echo session using your mobile device, and then use the queuing system of Meet Echo to put yourself in the queue. Slides are preloaded into Meet Echo, so it's possible for anyone presenting to share the slides. There is a button in the Meet Echo that allows you to share preloaded slides. It is possible to share your screen as well if needed, but ideally that's not needed and it's not recommended. We have a link here for the notes, and we would like to see if anyone wants to volunteer as a note taker. We would also need a Jabber scribe that basically is somebody who can relay comments from the chat into the microphone when needed. If anyone wants to do that as well, that would be helpful.
So I'm happy, as I mentioned on chat, to do the notes, so I can cover that.
Okay, thank you.
I would ask that if people are up at the mic, please do clearly state your name too. I know you'll also be queuing, but if there's conversation back and forth, we'll make sure that the remote people can tell who's talking.
That's excellent. Then we have a note taker. Thanks a lot, Tommy. Okay, these are the administrative pieces. So let's go on. A little bit of document status right now. We have the IOAM conf state and IPv6 options drafts in IESG review. And we have just done a second working group last call for the explicit flow measurements document. And I don't think we got any pushback on this second last call. So it looks like this one will likely make progress. Okay, we have a pretty packed agenda today. It's divided into kind of three sections. We're going to talk about adopted or working group documents, and we have a set of documents here. We will start with the newly adopted one, which are these performance measurements on link aggregation. Then we move on to the capacity protocol, encrypted PDM, responsiveness. We will not be doing the connectivity monitoring here. The slight update to the agenda. And then move on with data integrity, Yang, and stamp on SRPM. Then Greg will be doing a presentation on PAM. And after that, we move into the section which we call the lightning talks. So here we have a bunch of documents, a bunch of presentations. They should all be done as a one slider, pretty much similar but shorter than a hot RFC, but pretty much just present your concept on a high level, see if people are interested to collaborate with you further offline. So with that said, I think we can get started. And we have PM on lag first.
Can you hear me?
Loud and clear. Would you like to share the slides yourself, or?
Could you please share it for me?
Absolutely.
Thank you very much. Yeah, right. I can see.
Great.
Okay. Hello, everyone. I'm Tianran Zhou from Huawei, and I will introduce the progress of performance measurement on lag. These two drafts are adopted just after IETF115. And next page. Let's firstly recap the motivation. The lag provides an aggregation of multiple links. We want to measure the performance of each link. However, existing active PM methods run a single test session over the aggregation without the knowledge of each member link. This will make it impossible to measure the performance of even physical member link. So we followed the similar idea of RFC 7130, the BFD on lag. And next. To measure the performance metrics of every member link of lag, multiple sessions need to be established between the two endpoints and are connected that are connected by the lag. These sessions are called micro sessions. And the micro sessions need to associate with the corresponding member links. For example, when the reflector receives a test packet, it needs to know from which member link the packet is received and correlate it with a micro session. So we extend a new commands type to indicate the set of micro sessions of lag. And we use identifier to correlate the test packet to a particular microsession and carry the member link information for validity check. Next. This shows the OWAMP and the TWAMP extensions, including control message and the test packet. We add two new control messages, the request OWAMP microsessions and the request TWAMP microsessions. And in the test packet, we add sender microsession ID and the reflector microsession ID. Both IDs are locally assigned. Next. And this shows how the sender microsession ID and the reflector microsession ID are located in the authenticated mode. The next page. Stamp do not have a control plan, so only need to extend the test packet. The stamp TLV mechanism extend stamp test packet with one or more optional TLVs. So we propose a microsession ID TLV here. Next page. There are some discussions during the adoption core. It's about the interop issue because TWAMP Lite and Stamp are different on the format. TWAMP Lite sender with a Stamp reflector or a Stamp sender with a TWAMP Lite reflector may have issue. So our conclusions are, firstly, there is no requirement for such deployment. This only happens when misconfiguration. And so if there is misconfiguration, existing mechanism described in this draft can detect, then the operator can correct it. At last, an operator can choose not to use PM on lag and the micro session, but to use independent session for each link. So, and we will then describe this as operational considerations in our next revision. Next page. And as suggested by Rakesh among authors, next step, we will add a stateless process for stamp extension because stamp support both stateful and stateless mode. And stateless reflector may simply copy the received microsession ID in the reflector session ID. And here we would like to hear more comments. Thank you.
Thank you. Do we have any comments? Yep. Frank, please go ahead.
Yeah, I have one high-level question, and sorry for maybe my misunderstanding of what you're trying to achieve. But how would it work if you run stamp between two nodes and in between there are multiple lag segments sequenced one after the other?
It does not work, but we have mechanism to find this scenario.
So the scope of the work is only a scenario where you only have two where you
adjacent node.
Adjacent nodes. Okay, all right. I think that would be helpful to go and clarify right at the very beginning.
Okay.
Thank you.
Thank you. I thought we had Greg in the queue, but maybe.
Yeah, I was too quick to jump in the queue while the Frankenstein run already resolved. Just a note, so the use case and scope of this work is analogous to BFD over lag work, which is exactly as Frank noted, is only for single link between aggregation points. And it works only for lag. It doesn't work for MC lag.
Frank, you're still in the queue. Is it that you forgot to Or do you have, okay, great. Okay, thank you. If we have no more comments on this one, we can move on to the next point in the agenda, which should be capacity measurement with Al. Al, do you want to drive the slides yourself, or do you want me to share it?
We need your audio, Al. We can't hear you.
I'm going to get rid of the video now just because that's you can't really see me anyway. It's too dark here. And I'll try to share my screen. Okay. All right. Yes, I do. Select the window. Let's just go to screen 2. Okay. All right. So can you see the first slide?
Yes.
Great. All right. So this is the talk on the test protocol for one-way IP capacity measurement. It turns out we can do a lot more than capacity measurement with this protocol. So I encourage you to think about that. What we're responding to this time is the Security Directorate early review response, which is now pretty much fully implemented in the draft. And with an exchange with Roman Danilou of the SEC area AD, we want to have a little encrypted mode discussion. So anyway, moving right along here. So I sent this list to the IPPM list that describes the extensive changes in the protocol. The big changes are 4 newly defined modes of security operation. And I'm going to go into 1, 2, and 3 here more extensively in the next picture. But things you can't see in the pictures are the new key management and firewall configuration, the new subsection outlines, which basically align with each step of host processing for this protocol. So that should make it pretty easy for people to read and understand as we work our way through. We've got new security considerations where we discussed the attacks going back to IETF115, and a really expanded IANA section where we've got a new registry group, several registry groups to support the expansion of the protocol. So we're on slide 3 now. Basically, what I want to say here is that we have, for background, in the control phase, which is the top half of the slide, we're using 2 kinds of packet exchanges here: a setup exchange and a test activation exchange. And for the newly required authentication mode for the control phase, we've added the authentication digest and processing on all the requests from the client to the server and all the replies from the server to the client in both test setup, test activation. So that's a very complete authentication mode now. We've also got an optional authentication mode, which takes care of one of the messages of the data phase. So now going down below the control phase line into the data phase, we typically have our load PDUs. We send at really high rates. We can go up to 40 gigabits per second now in our running code. And we expect to get feedback PDUs back from the server, for example. So now the key information we're trying to authenticate here is the measurements that we conduct at 50 millisecond intervals and share back in the feedback, or depending upon the role. And that's an important piece of information too. So we can authenticate this. It's an optional mode. It might affect some of the round trip measurements we make here, and that's why it's optional. No big shakes there. The thing that the feedback we got, which we talked about at IETF 114, and then continued to decide not to do, is to add authentication, digest, and processing to the load PDUs. We're sending lots and lots of packets there. Very often, they're at the rate that the CPE can barely handle without doing anything extra, like authentication, and certainly not encryption. So these are, when these are the lightweight CPE, we can really get in trouble there. And we decided, there's really not that much information here to protect. So we're not going to add the load, the authentication, digest, and processing in the load PDUs. That's our choice for now. We've also got the completely unauthenticated mode, so that's available as well for folks who want to do this. So moving on to slide 4, Brian Weiss, who provided they very kindly provided the early SEC area review, suggested that we might use DTLS during the test setup and activation. However, it's kind of like I've said before here, the information we're exchanging there is very limited value. Test is starting. We got configuration of the test. You could easily fingerprint this and reveal that it's a measurement. There's no results there in the control phase. When we talk, back and forth with Roman, it's really the measurement results, the send rate structure. That's the critical information that's exposed. So DTLS doesn't help with that. We can only use it during the control phase. The retransmissions that it has, order delivery, they're not really helpful in the control phase. Data phase. So the most valuable information is communicated where DTLS can't help us. So we're not going to do this. That's our choice right now. So Roman, the security AD, asked us a series of very pointed questions, trying to lead us to the truth, which was very kind of him. And I replied back to that on the list. The key information we're exposing is during the data phase, the exposed measurements and rate control messages. They seem to require some form of encryption. So a simple solution here is to encrypt all the things, to operate the protocol within an encrypted tunnel. Excuse me. However, we've got this, when you have encryption like this, it's a bilateral agreement. The tests are point to point. So the users can choose their own encrypted tunnel and their keys and set it up, as they desire. There's plenty of support for independent tunnel implementations in Linux hosts. There's even hardware support in SmartNICs and data center equipment and so forth. So we strongly take the position here. There's no need to modify the protocol to use an encrypted tunnel. We'll simply say, here's a mode where you use the protocol and you set up your own encrypted tunnel. So, that turns out to be an advantage. Some users may want to characterize their own measurements in the tunnel technology they chose. So let's leave the choice to the users. The emphasis in IPPM is accuracy. So, we even recommend that some people who are going to use a tunnel run some tests unauthenticated first to see if the tunnel has negative impact. And you can purposely characterize the tunnel encryption this way. Very likely it's going to be that the capacity you see with an encrypted tunnel is less than the unauthenticated mode, or even the the recommended authenticated mode that people can use. That's still an option. So let's see. Oh yeah, and in the in the running code, we've got the MTU set at a fairly conservative value. So our case is that the if people want to use encryption, they can set it up themselves between consenting adults, and that's what we would describe in the draft. We don't see a need to modify the protocol to do this. It'll work just as well. So that's what we'll do in the draft. And this is the kind of thing I just wanted to talk about for a few minutes if folks have comments on this. All right, so I'll let people think about that while we go on to the final slide.
Martin in the queue.
Sorry,
Oh, okay.
client resets all the time, and I can't get in the queue. I'm sorry. I don't know if maybe I missed the explanation, but why can't you use DTLS to exchange the sensitive information?
Oh, it performs retransmissions and ordered delivery. So we make measurements on the feedback packets, and obviously the test stream. So we don't want the feedback packets retransmitted. We measure round trip time on those, and we don't want them reordered. So basically, the DTLS features, which are really nice, that that might make sense in the control phase, they don't help us at all when we're making our retransmission. I'm sorry, our feedback measurements for round trip time on the feedback PDUs. Does that make sense?
Yes. I mean, I guess the reason I'm hemming and hawing up here is that, I mean, it seems like this is a little scope creep on what this draft and what this design is doing, right? You're trying to measure capacity, and we have other tools to measure delay. I mean, it's certainly nice, but
hey Martin, it's definitely not scope creep, and let me take that on. We
okay.
measure loss and delay variation, and we use that information directly in our load adjustment or search algorithm when we're trying to search for the maximum capacity.
All right. All right. Thanks.
Sure thing. So here's the wrap up. I've still got a couple of minutes here. I think we'll have some more SEC area, maybe SEC directorate interactions. We'd like to agree to on a proposal for a fully encrypted mode, but we'd like to implement a working group agreed proposal. And for us, the bottom line is, as far as we can tell, even when we put in encryption in our protocols, it's not widely activated in the measurement protocols that are used to scale. You might see it going on between consenting parties, and that's fine. But OWAMP had encrypted mode, TWAMP had encrypted mode. We have 600,000 TWAMP instantiations. We don't use encryption in any of them. So look, if we have some agreement on this, we could spin another draft and maybe get a working group last call early to 2023. Maybe sooner if the encryption solution is simple. It's really just about wording and describing it. And I wanted to note finally here that lots of measurements with RFC 9097, the capacity metric, and round trip time under working load. Those are the kinds of things we've been sharing on the list very recently. And it points to the fact that, this protocol can be used for other things, working load assessment, capacity under working load, and so forth. We've got a lot of capability here. So let's, I don't really see this as scope creep. I see it as, using a tool that's really well endowed to make all the measurements we can. So thanks for your time, everybody. Any further questions, I'll be glad to take them.
Do we have any more questions for Al? I see Martin up in the queue.
Yeah, it's Martin Duke again. I went back and checked because I thought I was. Why is like DTLS doesn't have retransmission except for the handshake messages, right? I mean,
I thought it was retransmission for all the messages it protects. And when I said this last time around, I saw Tommy nodding. Maybe Tommy can help us out here, Tommy?
I think that it should just mainly be the the handshake messages that have the retransmission.
Yeah, I mean it's meant to go over UDP, so I mean like you would use plain old TLS if you cared about reliability. Yeah, so there's a retrans mechanism for the handshake, which is a different thing.
Okay.
I think it's similar. I mean, aside from security, I think like the transport guarantees are similar to UDP. So I'm not sure that the premise of this is correct.
Okay. No, I mean, my understanding was that, when I read about it was definitely talking about retransmissions. And
the handshake has to have that. So it does create like a mini TCP for the handshake. But after that, no, it doesn't have those guarantees.
Okay. All right. So DTLS would be applicable then, but I'd make the same case that if you really want if you really want to encrypt everything, then the simple solution is to put it in a tunnel.
Yes, certainly if the probe traffic you want to encrypt, you would need to do that. But obviously, as you are well aware, that potentially can influence the throughput you can generate, which may or may not be a problem.
Yeah.
I mean, it seems a little weird to say. I'll be brief. Sorry, I know I'm out of time. It seems a little weird to say, well, like you can do the test without encryption, and then do the test with encryption to verify that like it's not messing up your measurement, and do the test with encryption, because then like the data is then passing unencrypted, right? Which seems like a problem.
Well, I mean, if you did that once or twice before you started your tunnel, then you'd have those are the kinds of things that it's a really simple comparison. There's not that much information that's going to be exposed, and you're doing it quickly, potentially on a port that people would have trouble finding. So I think there's value in having that comparison, but the bottom line is you want to know whether the tunnel is affecting your accuracy or not, and with that little data point you can know.
Okay, so if the premise is that you're using some like other link that is not, you're putting on like a local host or whatever, so like you're running it through the encryption without actually putting it out on the line, I think that's fine. Anyway, I'll take enough time, so thanks. Bye.
Yeah, thanks, Martin. Thanks for the clarification. Go ahead, Tommy.
Hello. So I wanted to clarify for the next steps here around encryption. Since it seems like from this you're proposing, put it in an encrypted tunnel if you want, and I guess the other thing on the table is if DTLS does work, you could just say slap it in DTLS optionally. Are those the things that are on the table for this? Like, is the fully encrypted mode just going to come down to put it in a specific, in any tunnel you want, or is it going to be a specific protocol change? What are you thinking?
Yeah, a good question. I'm trying to avoid protocol changes at this point.
Right.
And I think it's really simple that people could, choose their own tunnel. They're likely to do that anyway. They're even likely to have the encrypted tunnel up and running anyway between consenting adults. So the answer is really simple. If you want to make these measurements, run it inside a tunnel, and there's lots of different tunnel choices. Why should we get into those details?
Okay. So this would be essentially an additional subsection that's like one paragraph long that says, hey, here's how you can run this in a tunnel and the impacts it may have in your measurements and how to think about it.
Yeah, that's exactly right.
Perfect.
So it'd be real interesting to find out how the security area reacts to that, and whether we can do this.
All right,
Okay.
then.
Well, thanks very much, everybody. I appreciate the corrections and the feedback today.
Thanks a lot, Al. And then we move onwards to encrypted PDM.
Let me see.
See if it works. Otherwise,
No. I pressed this one, right?
okay, just tell me to
Okay. Next slide, please. Okay, this is kind of the agenda. Let's go through that. Next, please. Okay, so in terms of implementation, we're changing to using eBPF. We used to have patches to the kernel, and eBPF runs in user mode, and we can use it on more platforms. So that's what we're trying to do just for the implementation. We can always support Windows. And we have it done for PDM-V1 and have been testing it. And now we're working on doing the PDM-V2 in eBPF. Okay, next, please. You can come talk to us at the hack demo and see the PDM-V1 stuff. Our proposal for PDM-V2 was also accepted into the IAB workshop. Very interesting workshop on managing encrypted networks. And we think this might be a very good way because certainly this is a big problem. Our thought is ideally, once we have a stable implementation, to co-locate PDM-V2 at various points, potentially with some of the CDN providers. Next, please. So the bigger question for all this is like, it's all well and good to define extension headers, but if extension headers don't work on the internet, it is an exercise in futility. So next, please. We have 2 drafts that we're working in V6 Ops, and we have also done an IEPG presentation. The bottom line, Nalini's opinion is that probably each H's work depending on the topology that you use. We will have a side meeting to discuss this on Thursday. We have done some testing using CDNs and cloud providers, and one cloud provider and one CDN is working very closely with us to try to fix the problems, because there are problems such as within a CDN, you'll get to the edge in IPv6, but internal to the CDN network, you are traveling in IPv4. And so suffice it to say that if you're traveling in IPv4, you're not likely to be supporting extension headers. So let us fix that problem first. So that is our big effort right now. We hope you agree that IPv6 should be supported in CDNs. So next, please. So as far as PDMV2 itself, there are 3 parts to the communication. There's the secondary to secondary, which is what this particular draft defines. But, and that is an independent protocol in itself. It is the PDMV2 encryption. But somehow you have to get the keys. You need a control protocol, or what we call a registration protocol, to create a common context and so on. That is what we are calling primary to secondary and primary to primary. The reason for this protocol is to make it a scalable, because otherwise you get essentially combinatorial explosion with too many secondaries. What we are proposing is that we leave this one clean, which is secondary to secondary, and start a second draft for the primary to secondary and primary to primary, because it's quite a bit. And so that is what we would like to do, is have 2 drafts. Next, please. So that's it. So yeah, any comments, thoughts? If we split the drafts as we would like, then just our opinion is possibly we're ready for last call. So I would like to get some thoughts. No comments? Has anybody read it? No, I'm teasing you. I'm teasing you.
Go ahead, Tommy.
Yeah.
Yeah, so just about the plan for the documents.
Mm.
If you were splitting this, we would need to do some kind of like adoption call, at least, or a consensus call within the group to say we want to have more different documents for this. I'd also be curious to know how much of the current document would be kind of generic between the different modes. Like how deeply entangled would these 2 documents be? How much are we buying by separating them out?
Yeah, that's a really good question. I actually think that we should take out, because we have in the secondary to secondary, what we have is some of the security requirements for the primary to secondary and primary to primary flow. I would suggest that we take all of that out. As I say, keep it clean, and then start the second document. So I would say that the amount of repetition should be relatively minimal. The reason I say this is that the reason for the split really is that, well, I guess I myself get really tired of reading 60-page RFCs. It's hard to keep your head straight, and so maybe, but I totally get your question. Maybe what we should do, I don't know what everybody thinks, is maybe just go ahead and create like a draft for what the primary and secondary and primary would contain, so you guys can kind of see, and leave a bunch of sections like this needs to be considered, this needs to be considered, this needs to be considered as TBD. That makes sense to you, Tommy?
Yeah, that does. I think having, we don't want to create too much busy work, but if you are sufficiently motivated and you want to kind of share it with the list, hey, here's how we think this split would be, here's our first cuts of those 2 documents. Then we can get agreement within the group, because something like that does need group consensus.
Sure. No, totally get that. And so why don't we go at least an outline of what sections there should be and how the two documents would look split apart. And then people can say, no, you should just really have them be one document. The other consideration too is that really, if scalability is not an issue for an implementer, you can just go ahead and separately implement the secondary to secondary. It really, if you just do secondary to secondary, probably if you get behind, if you increase to more than a handful of clients and servers, you will probably be doing a bunch of, shooting yourself in the foot by doing that. But having said that, if you do want to do it for a very small environment, that's certainly possible. That was another part of our thinking. Okay.
Great.
Great. So we'll go ahead and give you guys a prototype. Thank you.
Perfect. Thanks. That was very helpful. So the next presentation is on responsiveness, and it will be Stuart. It didn't work, it seems. So
that's fine. My name is Stuart Cheshire. I am presenting on behalf of Christoph Parsch, who is the primary author on this document. He's not able to be here in person this week, and it's 2 a.m. in California. So he asked me to step in for him. These are his slides. Let's go on. The responsiveness draft is a working group draft. Christoph is working on a couple of updates, which I'll describe in more detail. One is we discovered a flaw in the algorithm, that it can terminate too early and underestimate the buffer bloat. And the second issue is a suggestion for a well-known URI. So if we move to the next slide, I can describe this. So the goal, to remind everybody of the responsiveness test, is to measure the round trip delay when the network is actually being used. Most of the time right now, when we run a ping command on the command line, we're testing the network when it's idle, which is not very interesting because I want to know how the network operates when I'm actually using it, not when it's idle. So we do this by generating traffic that's representative of any normal upload and download. Let's move on. And in this example that Christoph made, let's assume the bandwidth delay product is 32 megabytes. And each TCP connection has a receive window of 4 megabytes. And that's why it takes multiple connections to fill up the pipeline. So the test starts with 4 connections, and they each grow to their 4 megabyte receive window. We have 16 megabytes in flight, but that's still not filling the pipe. So in the next slide, we add 4 more connections, and we observe that the aggregate throughput goes up. So that's great. Now, we can tell from this graph that we've hit the limit, but of course the test doesn't know that. So the test adds 4 more connections, and at this point, we don't get any more throughput because we have hit the capacity of our bottleneck link. And at this point, the extra traffic we introduce into the network is sitting in a queue on entry to that bottleneck network. And that's what we want to measure. We want to observe what is the depth of the buffer bloat in this network? How much is it willing to delay our packets and make them late? With the current test, this is where it terminates, because it sees that the latest round of adding connections did not increase the throughput significantly. So it concludes, I've now filled the full capacity of the pipe. My measurements are done. You can see from this graph that it may have filled the full capacity of the link, but it has not yet filled the buffers. And in real world operation, it's very likely you would fill the buffers until they overflow. So this risks underestimating the true buffer bloat of the network. And if we move on, the solution to this, very simple. It is described in the issue tracker in GitHub. All of this is tracked in GitHub, so we welcome any suggestions from other people who notice mistakes or have ideas for improvements. The solution is very simple. Instead of terminating the test when the throughput stops going up, we monitor both throughput and delay and terminate the test when both of those are stabilized. So simple fix there. That's going in the next version of the draft. The next suggestion, next slide, please. Sorry, I used the clicker if it was working. This is another suggestion we had. Because this responsiveness test is basically built on HTTP gets and puts, any web server is a suitable platform for running this test. So there's a suggestion that we have a well-known URI of a configuration file in JSON format. So any web server, and maybe in the future this would be built into standard web servers, that they all support doing responsiveness measurements. And the way you find this out is by querying the well-known URI and see if you get back a configuration object. Next one. We have a couple more issues tracked on GitHub that are in the pipeline. One is that I described earlier that you keep adding connections until the results stabilize. Sometimes they don't stabilize, and it can be hard to tell if the little fluctuations are significant. So because we don't want the test to run forever, sometimes we have to terminate before we're totally confident. The other issue, we've been talking to home gateway vendors, companies that make NAT gateways and Wi-Fi access points. And one of the really important things for diagnostics here is to narrow down where the buffer bloat is. So anybody in this room can pull out their iPhone, you can run the Apple responsiveness test, or you can run the Ookla speed test app, which now it also includes a similar working responsiveness measurement. So now you know you have horrible buffer bloat, but where is it? Do you blame the ISP? Is it your Wi-Fi access point? The next step you want to do is diagnose that. We've had interest from equipment vendors to host a test endpoint on the home gateway. So you can run a test from your iPhone to the home gateway and tell if maybe your Wi-Fi access point is where the buffer bloat is occurring. Or the home gateway can test upstream. You could imagine if it's a cable modem or a DSL modem, you can divide and conquer and try to narrow down where the buffer bloat is happening. A lot of these home gateways, for cost reasons, are not built with more powerful CPUs than they really need to get the job done. And we've had strong feedback from them that doing TLS at a gigabit per second is beyond the capabilities of their hardware. I know my iPhone can do it and my Mac can do it, but a little $50 home gateway box can't. So there is a request to support unencrypted capacity measurements as well. That's something we're going to work out how to put into the draft. It's not totally obvious how to do it for the same reason that HTTP and HTTPS don't run on the same port. There isn't a good in-band negotiation way to say, are we using encryption or not? But we will sort that out. And I think that's our last slide. So yes, I will answer any questions if people have any. Of course, file issues on GitHub, and Christoph will be available via email to answer any questions too.
All right, we have Al in the queue.
Thank you, Stuart, for stepping in for Christoph. I know he appreciates it. I'm wondering if you're familiar with any of the measurements we've shared on the IPPM mailing list recently. They tend to point to, the underestimate of capacity and therefore working latency that you guys are talking about. And what what we saw basically was that the RFC 9097 IP layer capacity measurements produced higher latency because we have we sort of have a stronger method of producing the working load and expanding the buffer bloat in the channel that we're measuring. So we saw, I mean, to be clear about the numbers, we saw, like on a 1 gigabit downlink, we saw, the full gigabit measured with the IP layer capacity tool. We saw about 900 megabits with responsiveness and the capacity of reports. And when we tried the Go responsiveness version, the capacity was very much lower than that, on the order of about 120 megabits per second, when it should have been, a downlink capacity of 940 megabits. So, we definitely saw the kind of problem that you guys are saying you're going to attack this time around. The latency is a good thing to monitor, but it may be that there's faster ways to get there and to measure the working latency than adding one connection at a time. So I just encourage you to think about that and also consider the measurements that have been shared. Thanks.
Let me understand what you're saying, Al. Are you saying that the algorithm as described in the draft is flawed, or are you saying the current implementation written in Go is not as efficient as it could be?
Well, both those things, because you guys are saying that the algorithm based on throughput is flawed, and you want to change it.
I wouldn't state it quite that strongly. That this software is still in development, and this draft is draft 01, so it's a fairly young draft. The existing code would look for the throughput to stop increasing as it signed that it had filled the link. And actually, it was me who pointed out the issue. I was thinking about this, and I said, just because the throughput is no longer increasing doesn't mean you filled the buffers, because the round trip delay might be still going up. So that's not a particularly profound observation. That was just something I realized, that we should wait until both of these measures have stabilized. So I don't think that's some fundamental flaw in the way it's measuring capacity. It's just a slightly different condition in the while loop about when to stop. As to your comments about it was only reporting 900 and something megabits on a gigabit link, do you have any, can you explain, do you have a quick summary about what you think was causing it to not get the full gigabit?
Well, in general, TCP with multiple connections, has some instabilities about the throughput that it measures, and without a lot of averaging that some of the companies use, you tend to get variations from measurement to measurement, and also some just some interaction problems that I think Matt Mathis can explain to you very well. So the issues here are in some sense choices, and that the fact that you're adding additional information to the algorithm now, that may work out very well, but right now the capacity estimate is quite low, and that's resulting in a working latency which is low as well. That's at least according to our measurements. So, I'm just trying to share some experience that non-developers have had, and it's been shared on the list. So, I hope that you guys will take that for what it's worth. Thank you.
It sounds like your feedback is that it's your observation is that you disagree with using TCP with qubit congestion control, and it should be something else, that's some other transport protocol that's filling the network. Is that,
no, I'm not disagreeing.
TCP is the wrong protocol? I'm not sure what you're saying.
TCP had, when you add a lot of TCP connections together, there's an instability that results. And Matt, like I said, Matt Mathis can explain that to you very well. In fact, he explained it very well in an RFC that we wrote here in IPPM some years back on model-based methods for measuring the capacity.
So you're saying TCP is the wrong tool. What is the right tool?
Well, if we want to measure IP layer capacity, it's RFC 9097, and we've got an RFC for that.
Okay, thank you.
Thanks, Al. Martin?
Martin Duke, Google. Maybe this is a dumb question, but you mentioned the use case of measuring buffer bloat to the Wi-Fi access point, but isn't that like a single hop? Where's the buffer bloat in that case?
The buffer bloat is in the Wi-Fi chipset in the access point that is a big black hole that sits on packets for half a second. So when data comes in over your cable modem and over your gigabit Ethernet into the access point, for most people, unless you're sitting right on top of the access point, your Wi-Fi rate is less than a gigabit. So if you're downloading data, a software update, an app, you're watching Netflix video, your Wi-Fi access point is the slowest hop. And that's where the queue builds up. And depending on who makes that access point and the chipset inside it, you might have half a second of queuing, 2 seconds, 5 seconds. I have been doing some tests on, I won't say which vendor, but one particular access point that has 5 seconds of buffering. So you can measure. Packet comes in, sits in RAM chips for 5 seconds, and then gets delivered to the Wi-Fi client. So Wi-Fi access points right now seem like they're the biggest source of delay on an end-to-end internet path.
So by directly connecting to the Wi-Fi point, then just like if it's generating data coming back at you in this test, then you would then obviously fill the buffer for that access point. Or are you connecting something beyond the access point to?
Both of those
Okay.
are envisaged. So most customers have an integrated box. They have a cable modem that's cable modem and NAT gateway and DHCP server and Wi-Fi and an Ethernet switch all in one box. There are other people, probably some of the people in this room, who have more of a component system with a ubiquity unified Wi-Fi access point that's just a Wi-Fi access point and some other box that's being the NAT gateway and so forth. So each of these bits of hardware could run a little web server serving the right URLs for doing the responsiveness test. Mm-hmm. And that would give the client on your device multiple vantage points in the network to hit, kind of reaching further into the network to narrow down where the buffer bloat is happening.
Thank you.
I mean, to give one example, it doesn't help the customer to call their ISP to complain about buffer bloat if the buffer bloat is actually on the Wi-Fi access point they bought themselves. So, but we have also measured cases where the cable modem CMTS equipment at the ISP is configured depending on what data rate you're paying for, 50 meg, 100 meg, 200 meg, they configure the queues for 2 seconds of buffering at whatever rate you're paying for. So again, under load, every packet you receive sits in RAM chips at the ISP for 2 seconds while it sits and twiddles its thumbs, and then it comes out. So you've got a gigabit in, 2 seconds of going nowhere, gigabit coming out the other side. So you could have 2 seconds of lag in the ISP, you could have 5 seconds of lag in the Wi-Fi access point, and knowing which is afflicting you is really important to know what to do about it.
Thanks. Tommy?
All right, thank you. So first, there's not the reason I got in queue, but just to call back to the conversation with Al, I would encourage you and Christoph and the others to look at the stuff that Al wrote to the list, because that does have a lot of details. And, even I certainly think there's room for different methodologies. And the point of this is not to measure capacity, but at least understanding the comparisons and the difference in the measurement results will be good.
Yeah.
So I came in just about the kind of the unencrypted mode, looking at the JSON, because I assume that your well-known URI will contain the JSON that's currently defined in the document. It does seem that that includes the URLs of the different test
Yes.
test URLs. So would we imagine that the client could fetch the well-known URL at HTTPS such that the test server does support TLS, but then points you to unencrypted URLs for the specific download files? Could that work?
Yes, thank you, Tommy. That's a really good observation. We were, I think we were thinking too much in binary, all or nothing, black and white, that it's either
Right.
clear text or it's TLS. And your point is really good, which is the problem is not that these devices can't support TLS. They can't support TLS at a very high rate. So yes, thank you. I think that's a good insight. The configuration blob will always be fetched over TLS, but the actual high rate test traffic can be optionally unencrypted. Thank you, Tommy. Good
Yeah.
idea.
And just one more comment off of that, of just something that will need to change. Currently, your test is always done explicitly over HTTP2. Of course, when you're unencrypted, that will not be an option. So we'll have to go to HTTP1, which will have different flavors of performance as well. So that's going to need to be a consideration.
Okay, let's think about this a little bit more.
Yeah.
I know the intention of HTTP2 is that security is not optional, and for traffic on the public web, that makes perfect sense. For this kind of benchmarking traffic, my understanding is that there's nothing about HTTP2 that says you can't run it directly over TCP. You're not supposed to, because it's supposed to be tied to TLS. But
right, I guess, I mean, you can, but I don't know if we want to be encouraging implementations to kind of, for this reason, build the unencrypted HTTP2 mechanism. That it's something that is not normally supported, and so you need more exotic implementations or more knobs that some of the languages we may have may not support today.
yes, but let's think more about the right way to do that. It's not as simple as just saying we'll use HTTP1, because part of the way the test works is it's fetching large chunks over the H2 connection, and then in the middle of that, it inserts a GET request for a little 1-byte object. And that's how we're measuring on a working busy connection, how quickly can it deliver some other piece of data on demand. And that ability to interleave multiple requests is not there on HTTP 1.1. You can do pipelining.
Yeah.
So yeah, we'll need to think about the right way to do that.
Yeah. All right, that sounds good. And sorry, one final. There's just a curiosity question, because as we were talking about this in HTTP2 versus HTTP1, in general, the document and this presentation, we're talking about having multiple TCP connections here. How are you inducing the HTTP stacks to create multiple TCP connections when they're doing HTTP2? Because generally it will try to use one.
That's a good question. I don't know the specifics of. I'll give you my best understanding of this, that on the tools on macOS and iOS, I think it's using the URL session APIs, and by making, most applications make one URL session and use it for everything. I think this code is explicitly making multiple URL session objects, and the connection pooling is per object. As to what the Go responsiveness test does, I have not looked at the source code of that, about how it is steering the underlying code to open parallel connections.
Yeah. Okay. It may be worth a note, like to implementers, to be careful about make sure that whatever API you're using and whatever language you're using is letting you have that control.
Yes, yeah, that's a good point. A client could make 4 different calls to an API to get a URL and not realize that under the covers, those are all being coalesced into one connection.
That's right. Okay, thank you.
Great. We have a little bit of time, so I just want to insert myself and ask one more question. I was wondering if you have considered these tests in certain mobile scenarios. So imagine that you're running this from your device on a mobile network, and you're on a high-speed train, say. So you start your capacity measurement or your responsiveness measurements while you're in one cell, and then you might hand over to a different cell with completely different properties. For instance, going from one 4G cell to a 5G cell, maybe in the first cell, you sort of, your algorithm thinks that you found the capacity and you start measuring the delay, but then you hand over to some cell with much higher capacity, and then that would probably lead in the delay dropping. Is this something your algorithm is currently considering? That, I mean, if you start to see a delay buildup, but then the delay drops, and would you then kind of try to add more throughput into the?
I think the simple answer to your question is we have not considered those kind of changing environments.
Okay.
One of the things we have considered, just for usability reasons, is that our goal is for the test to complete in about 10 seconds.
Okay.
This is the kind of test where you pull out your phone, you run the test, you wait, you see the answer. It's not something that takes 5 minutes to run. So by keeping it short, I think that reduces these kind of opportunities for conditions to change. I can't imagine a fully general solution to the kind of situation you describe, which is however long the test runs, just as it thinks it's done, suddenly the whole environment changes. The same could go if you're sharing capacity with some other client and they finish their download and suddenly there's twice as much share available for you. I think it's always possible to construct scenarios where those changes happen at just the wrong time, and you don't notice the changes happened. I think the answer there is at the human level, if you run the test 2 or 3 times, hopefully you get consistent results. The other thing to remember for this test in particular is the focus of this test is not how many megabits per second are you getting, because there are many, many tests that already do that. Everybody runs IPERF and many other ways of testing capacity. The focus of this test is to work out how deep are those dark buffers. And our belief is that the depth of buffering actually is not something that varies with time of day. It's not something that varies with traffic. It tends to be a configuration option of the network hardware, and as such, it's relatively stable. Now, if you roam from one mobile cell to another one, then you might inherit a completely different configuration. Just like if you were to roam from one Wi-Fi access point to another, you could end up in a dramatically different network environment. I mean, to give a silly example, right? You could have one Wi-Fi access point plugged into a 1 megabit DSL modem, and you walk next door and you roam to an AP that's plugged into gigabit fiber. And a lot of the time that roaming is completely transparent to the application. If your IP address hasn't changed and the SSID network name hasn't changed, the application doesn't even know. It's just suddenly the configuration is different.
Okay, thanks a lot.
Thank you.
So we move on to data integrity, IOM data integrity. I don't seem to get this one to right.
Hi, morning. So this one is going to be pretty fast. Actually, we have no change since the last IETF. The reason is simple. We were waiting for the implementers to have a feedback on the implementation as we agreed. So I think we're going to wait a little bit more. So I think also that it doesn't change anything about the working group last call. So we're going to postpone it to maybe, I hope by next IETF, we will have some feedback on that. And regarding the email we received from Ayana, so I just wanted your advice on that. Should we just annotate the code points with the suggested mention, or should we just ask for early allocation? So this is a question for you, Marcus or Tommy.
Yeah, I think we need to review that offline.
Yeah, sure. Let's take that to the mailing list then.
Any more comments on that one? Frank?
Justin, would you mind expanding a little bit on why the delay happened? I think that would be helpful for everybody to understand.
Well, actually, there was a student for that, and it turned out that it was quite unreliable. So, you know, things happen, and now we have another student, which is a master in the University of Liège, and so this is a master thesis. So I for sure hope that it's going to be okay this time.
All right.
Thank you.
Then, yeah, thanks a lot. Then we have IOM Yang. Do you want me to share?
Yeah. Could you please share it for me? Okay, thank you very much. Hello everyone. I'm Tian Zhou from Huawei, and I will report the progress of the IOM Yan data model. We received comments from the working group last call, and thanks Tom and Greg for the very useful discussions. There are some minor issues. We will update the new revision, and there is a major issue raised by Tom to add some examples. We are going to accept, but still we can discuss later whether it is necessary. And next page. And there are many discussions raised by Greg. Most of them related to the scope of IOM, like whether IOM DEX is an integral part of IOM or not. I'm going to reduce the scope of this document to align with the RFC 9197. That means IOM DX and IOM flags are excluded from this EM model. And then the first question, whether to include the presentation of IOM data. My suggestion is YAM model only focus on the configuration. This YAM model can only focus on the configuration because the export may not use YAM model. For example, IPFix could be used. On the other hand, the export should be IOM independent. That means there are other measurements could generate the same metrics like delay, loss, and so on. And on the last question, should the configuration of IOM over IPv6 or NSH be part of this document? I would say yes, and I do not think we need to augment the ACL model here. The filter defined in this defined in this draft is only used to identify the target flow, which does not have an IOM header. When matched, the packet will enter the IOM process. We can use the protocol entry in this draft in the YARN model to find the IOM instruction. In addition, YARN just provide enough information from the configuration interface. A device may have different implementations. Yeah, and that's all.
Thank you. Oh, we have Frank in the queue. Go ahead.
Yeah, maybe I'm going to go and ask the same questions again that Tianran already asked. There is, in many cases, people supplying examples for Yang models. We can go and create a foo example as part of the document. Feasible, doable. Though we also have to recognize and acknowledge that there is no implementation yet. So it would be really a made up example that we can go and put into the document. And I'm just wondering how useful that is. So we can even go and consider moving the overall document to experimental instead of standards track. And then just that way saying, well, yeah, we can go and have a mock-up example of a Yang model. If we look at other management documents that we've done just recently, like ConfState, there is no examples in there at all. Right, so I'm just wondering whether people have a feeling for or some guidance on whether we want to put a foo example in, whether it's useful, or whether we should just go and leave it for now, recognizing that this is like early stages and we're waiting for reference implementation. And then the second thing that Tianran already mentioned is I would be very much in favor of following the suggestions that Tianran had, i.e. we focus the scope on the core IOM documents, so 91, 97, and that way avoid like forward references on other documents that are still in flight and making that a little like nebulous on what the scope of this document would be. So if we can go and scope this document also to 91, 97, then a lot of the problems that were brought up in working group last call would naturally resolve itself.
Greg, let's go ahead.
Hi, Greg Mercy. Well, I understand that desire to move forward and progress this document, but I see that IAM DAX is important and very much needed mode of IAM, especially in an environment with their constraints, so that because it allows for export of operational state and telemetry information out of band or for the management plane, for example. So I'm concerned that if there is no effort to drive this work, and I don't see any draft, individual draft, or any draft of any maturity that addresses it. So narrowing scope of this draft at this point seems like a risk of IAM DAX Yang model would never be done in time, because I can point to work and discussion we have, for example, on MPLS architecture enhancements using the network actions, where IAM DAX is very attractive, and especially, for example, in deterministic networking with the MPLS data plane, where their resources allocated for DetNet flows are explicitly reserved, so that even their operational state and telemetry information are important. Exporting them is not critical to delivering DetNet services. So, and thus, IAM DAX is very valuable mode of IAM, especially for these environments.
Yes, then there will be several choice. One is just as I suggested, exclude this IOM DEX, or on the other hand, maybe we need to um, uh, to have a consensus on how to operate the IOM DEX, like where to that like the ACL in the at the transit node. I think this is still not clear right now.
Okay, if you want to respond quickly to this one, Greg, then we have to move forward.
Yes, I agree. I think that having this discussion before we make a decision on how to progress this work, it will be very useful and helpful, not only to the group, but to the larger community that is looking to use and apply IAM technology in their use cases, networks. Thank you.
Thank you. So let's move onwards. We have Rakesh with stamp on SRPM.
Good morning, everyone. My name is Rakesh Gandhi, and presenting the simple the stamp extension for SR networks on behalf of the authors listed. Next slide, please. So the agenda is the updates that we have made in revision 06. We'll briefly have a look, highlight the stamp-based work that's being done in other working groups, and the next steps where we are and what we should do next. Next slide, please. So in the latest revision 06, we have addressed various review comments. Many thanks to Rick and Greg for providing the comments. So comments from Rick from Spirent regarding the VCheck flag for the status reflector, specifically for the counters for the direct measurement TLV. So we have added the text for that. We have also addressed various review comments from Greg. Many thanks, Greg, with clarification text for the V flag destination address TLV and written path TLV. So we have also done the IANA early code point allocations to facilitate the implementations that's going on. And we have added that in the draft as well. A few minor editorial changes, and we had no open issues right now. And next slide, please. So there is ongoing work to extend STAMP. It's a great protocol work done in IPPM, and we are using that in Spring heavily. A few drafts there, as well as this one for MPLS as well. So please review this draft as well as and provide review comments. And next slide, please. So for this draft, currently we have no open issues, and we believe the draft is ready for the working group last call. So we'd like to request the working group last call.
Okay, thank you. That is definitely something we'll consider then. Yep.
Yeah, so that's all I had. Many thanks.
Thanks, Rakesh. Any comments?
Yeah, thank you.
Right, thanks. Then we move onwards in the agenda. We will have Greg to talk about PAM.
One of the benefits to being presenter. Yes, we can go to the next slide, please. Okay, so let's recapture what we're trying to address here. Service level objectives are components of service level agreement, and they reflect on key performance metrics that are critical to user experience with a particular service. So in some use cases, the whole history of each SLO is not needed. And what is important and critical is capturing when their SLO are violated or not being delivered. And that's sufficient to draw the conclusion of wellness of their service being delivered. So basically how much it in regard to SLA. And the second observation, so you can see here on a drawing that what matters here is that when a particular SLO is outside of the range. And there could be a different interpretation. So it could be that, for example, operator is interested in early warning about their dynamics or degradation of the particular performance metric, and will request that the system, the PAM, will inform about the violation of optimal threshold. Whereas that operator and customer will be interested in knowing with the degradation crosses critical level. So for that, we allow in our approach in the discussion in this document that there are two types of thresholds might be associated with their any given SLO. Next slide, please. So what are they? We received excellent comments from Adrian, and he agreed to join us and collaborate together. Welcome, Adrian. Thank you. And we worked together in addressing his comments and other comments we received in the meantime between meetings. Next. So what we wanted to emphasize is that one of the use cases for PAM and SLO is IETF transport slices. And if we look at the draft that being worked in the TS working group, so the definitions clearly state that SLA is composed of SLOs and service level expectations. And service level expectations, unlike service level objectives, they can be expressed, but they're more challenging to measure. So thus, SLAs are outside the scope of this work. Next slide. Usefulness of metrics. In the foundation of this approach is that for each given SLO, their associated performance metric is measured over predefined interval. And that is the same interval being applied to all SLOs that are part of the same SLA. But at the same time, because their decision of transition between availability and unavailability state is done based on the number of consecutive intervals that can hide or their notion of number of transgressions, violations is lost. So that's why the ratio metric seems to be a useful metric. So, and the ratio can be applied equally to violated intervals. So when there are optimal thresholds being crossed, and severely violated, where their critical thresholds can be lost. Of course, if only one threshold critical is defined, then the metric for the violated intervals will be identical to the severe violated. Next slide. please, if you have any questions, let me know. I don't see their queue, so. Okay, so let's continue. In discussion of IETF network splicing, what's important is that a network slice can be constructed using a set of connectivity constructs. And these constructs it could be a point-to-point, point-to-multipoint, and more about it in more details, you can look at NBI, Northbound Interface Yang model for network slice. So that an SLO can be applied or assigned to all the constructs that are included in the composite service, or subsets of constructs can be assigned different sets of SLOs. So thus, it allows to monitor individually these subsets of constructs and draw a conclusion, learn about their availability, unavailability state, and in turn, so that the composite service will be a composition of these subservice PAM indicators and metric. Any questions about that? And why it seemed to be important? Okay, let's continue. So we still have some questions that we want to discuss, and we are discussing with authors, and we invite your comments, suggestions, and contributions. One of them is individual packet metrics, whether it's important or it might be too burden. It might be an optional. So we, as originally we indicated, so that future work in this direction will include Yang data model, IPFix extensions, support statistical SLOs, and more defining the policies that guide monitoring service level objectives. Okay, so next. As I said, we always welcome comments and questions and contributions. So we would like to better understand their state of the working group adoption poll and resolve questions that are being raised during adoption poll. We have a working version that includes updates applied resulting from the comments, but I believe that we still have one discussion that needs to get some closure, or at least we would like to understand what the status of the working group adoption poll. Thank you.
Thank you, Greg.
Yeah, thank you. Just regarding that adoption call, we did, in general, we had decent feedback. I would point out, a number of the support was coming from co-authors, and so, we don't count that quite as much, of course. So, we definitely had decent support. There wasn't a lot of detailed feedback in that. And then the one main piece of detailed feedback was from Benoit, and that unfortunately hasn't gotten more response. So I think when the chairs discussed, we would like to see some resolution or more discussion there, or alternatively, more in-depth comments or reviews from other people. So I don't know if Benoit was, in the room or watching this discussion. I don't see him, but if you could also try to help reach out, or if others in this room, if they are interested in this work, please feel free to chime in on that call for adoption thread and add support, because at this point we're kind of 50-50, I'd say, as far as getting consensus here.
Yeah, I understand. Offers and contributors, I'll just refer to offers. So we discussed Benoit questions and comments and responded to him during their 2-week period of adoption poll. But for some reason, we heard nothing back from him, whether our responses. What we believe is straightforward updates that been already incorporated in a, based on his comments, incorporated in a working version that is not uploaded yet, because we felt that, yes, I agree that it's beneficial to have a conclusion, but at the same time, it's not clear that his comments are really that critical that basically cannot be resolved in the course of the discussions as the document progresses. But that's probably our author's view.
Right. That's fair. I mean, one option certainly would be to, if you have this working copy and you have other changes, upload a new version. We do a new call on that version. And if we don't, if we get consensus and we don't get objections, then we can move forward.
Okay, that's a good plan. I agree. We'll follow through. Thank you.
Sounds good. Thank you.
Good way forward. Thank you. Okay, now we're moving into the lightning talks section here. So we'll have a bunch of presentations and they will be rather quick. So please really try to make your presentation short and crisp. So we will start with the enhanced alternate marking.
Yeah, this is just a one-slide presentation. So to present, to introduce this draft, and I'm going to introduce what is the rationale and the background for this new draft, why we want to augment alternate marking. So maybe you know that RFC 8321 bis and RFC 8889 bis are in the RFC editor queue. So the work is quite completed. I also want to keep the occasion to thank Martin for the great help on this. But however, there are some pending points that we want to explore. For example, in some protocols, there are no additional bits that can be used. And also some deployment experience give new requirements. For example, the entropy of the pseudo-random flow identification can be increased in some cases to extend the number of flows that can be monitored. And there is also another point that we want to take into consideration, that is the implementation of the whole framework, included the multi-point measurements. So that's why the draft aims to consider all these aspects and generalize the alternate marking data fields for all the transport protocols. So in order to introduce new metadata, new flow monitoring, flow identification extension, and new flags. So the extended data fields can be used for several applications to have a shortest marking period, have more dense delay measurement, increase the entropy of the flow monitoring identifier, and automatically set up the backward direction. So this is the scope of the draft. So please read and share your feedback on the list. So I think
great.
It's done. Okay.
Thank you.
Yeah.
And next up, we should have distributed flow measurements.
Yeah, can you hear me?
Yep.
Yeah, thank you. Yeah, hello everyone. I'm Hojie from China Mobile, and on behalf of other co-authors to share two drafts with the topic of in-band flow measurement in IPv6 network. The first draft is about distributed flow measurement. Next slide, please. So as we all know, in-band network measurement utilizes controllers to collect measured data and calculate the packet loss and delay. On the other hand, in a multiple domain scenario, intra-domain controllers collect measured data of each aid, while inter-domain controllers calculate the end-to-end results. Their interaction is recorded. The controller interaction induces complexity and degrades the insanity of measurement, which is risky to guarantee the high SLA requirements of customers, such as banks and financing. So we would like to propose a distributed flow performance measurement method without the participation of the controller. The measurement results could be used by the router to select the forwarding path that meets the high SLA requirements. More details can be found in the draft. Next slide, please. The second draft is also about flow measurement in IPv6 network. Next slide, please. So in the previous presentation, Tiana and the co-authors have proposed the IPv6 auto-marking options to provide enhanced capabilities and allows advanced function abilities. This is helpful to application and deployments. On path flow measurement, that is also called in-band network network telemetry, is researching and deploying in China Mobile. From the test results in our lab, it is better for flexible deployments on condition that a node ID and a steerable measurement period can be enabled in the data plan. So to flexibly deploy on-path flow performance measurement based on auto-marking method in IPv6 domain with the participation of controller, a node ID and a steerable measurement period is urgently demanded. More details can be found in the draft. Next slide, please. So in the next step, we will continue to improve the draft, and any comments and feedbacks are welcomed. Thank you.
Great, thanks a lot. Next up, we have the devices explicit measurements.
Hello everyone, I'm Fabio Bulgarella from Telecom Italia. Today we want to introduce this new draft. This is the user device explicit monitoring. And next slide, please, Marcus. In this draft, we want to propose to put the explicit flow measurement probes directly on the user devices, for example, smartphone, tablets, or personal computer. This new idea has some advantages. The first one is the scalability, because on the user device, there are few connections to monitor, and it does not need so much resources to monitor all of them. Using the probe inside the user device give the possibility to obtain more precise measurements. For example, if we consider the client, the delay, we can remove the client application delay from the measurement, so we can measure only the delay that is on the internet path. Obviously, another advantage is that the monitoring of both direction is guaranteed, and another big advantage is that we can save on network monitoring equipment, because there could be a sort of user device and network props coordination. So, for example, it's possible to set alarm thresholds on a user device that signal to network props which session has to be monitored, and network monitor equipment can concentrate only on those sessions. And we have also the possibility to improve some metric, because, for example, the qubit that is not end-to-end can become end-to-end if the probe is placed in the user device, and L-bit measures are not affected by losses, so are more reliable. Obviously, this proposal does some assumptions, some privacy-related assumptions, so the device owner decides whether to traffic is traffic or not. So there should be some sort of decision that the device owner can do in his device. And the device owner can also decide if share his performance data with only with his internet service provider, or, for example, also with national authorities for stats or other evaluation on the performance. So if you want to collaborate, you can contact us.
Okay. Just a very quick question.
Yeah, Martin Duke, Google. Like, assumption's an odd word for like what the device owner decides and has the power to decide to do. And I mean, I think you're right to consider the privacy considerations here, but I'm concerned that this become a mandatory requirement on some networks, and thus, not really be an optional forfeiture of privacy, but rather a mandatory one. Thanks.
Yes, it's mandatory. Yes, I think so.
Okay, great. Thanks a lot. Next up, we have MPLS stamp. Great.
Thank you.
Okay, next slide. So this is just to bring to your information the work started an MPLS working group to extend LSP ping with ability to bootstrap stamp session with some state associated at session reflector. So those familiar with LSP ping will notice that it's similar with how LSP ping is used to bootstrap point-to-point BFD session. There are proposals of extending LSP ping to bootstrap point-to-multipoint BFD session. So this follows this similar paradigm of using an extension to LSP ping to bootstrap stamp session, whether it's a point-to-point or point-to-multipoint. And more extensive discussion will be this week at MPLS working group session. Any questions? I encourage you to come to an MPLS working group. Thank you.
Thanks a lot, Greg. And then next up, we have path consistency over SRv6.
Hello, can you hear me?
Yes.
Okay. Hi everyone, I'm Sejun from China Mobile. I will report this draft about the path consistency over SRv6. Next, please. When measuring SRv6 policies through stamp or QApplet, it is important to ensure that test packets and reply packets are transmitted along the next animal. That is to ensure that the path is consistent. If path consistency cannot be guaranteed, there will be some issues. For example, the delay measuring is inaccurate. For the time step carried in the reply packet don't belong to the path of the test packet. Moreover, measuring of one-way delay requires high precision of clock synchronization in the network. In addition, the measurement occurrence is not enough for the packet loss, even it may be not conformant with the fact as shown in the right figure. But when the transmission paths of the test packet and the reply packet are consistent, there is no packet loss as shown in the bottom right figure. But reply packets may be discussed because they are forwarded through IP. So in this draft, we process a method to keep the path consistent, and when measuring SRV 6 pulses through stamp or triplet, we use the path segment to associate the transmission path of the test packet and the reply packet. By this way, we can solve those above issues. That's all. Any question?
Thanks. We have Sasha in the queue here.
Okay. Rakesh Gandhi from Cisco Systems. So there is a draft in Spring that talks about using the path segment as well for the SR path for stamp. So please have a look at the draft and let us know if there is anything missing. Thanks.
Sasha, if you're in the queue by mistake, you can remove yourself from the queue, or do you have a question?
Oh.
Okay, then we'll move on to the last presentation here.
Oh, thank you.
Altmark, yeah, thank you.
Okay, can you hear me?
Yes.
Okay, thank you. I'm Wang Minxue from China Mobile, and on behalf of other authors, I will present this young model for the alternate marking method. So I want to first explain the alternate marking use cases in China Mobile. So for the diversity of the service type and the SLA differentiations in the 5G period, it brings great challenges to the performance monitoring of the backhaul networks. So in China Mobile, we have the 5G backhaul network, which is deployed 400,000 MTN devices. MTN is defined in IETF G.A3 10 and uses alternate marking to do the service flow level performance measurement and accurate fault locations. So, and we also planned to use the alternate marking to provide the accurate performance monitoring for the dedicated line service in the very near future. So why we need a young model for the alternate marking? So as you know, it's a large scale for the backhaul and the metro networks in China Mobile, and we need a consistent young model to manage the performance monitoring across different domain or different vendors. So we propose a young model for the alternate marking. And we have three objects here, the global object and head node and end node. So in global object, we have some label and also some FII mode for the global configuration. And in head node, we can configure the flow ID as a key parameter and also the alternate status, period, hop by hop status, MAC IP, and the interface name as and there are some other parameters, and I didn't list here. And for the end node, also can configure the flow ID, VPN period, and hop by hop status, and the if names. So this is our proposal. Thank you. We are welcomed any discussions and comments. Thank you.
Thank you very much. That was our last presentation, right on time. So thanks everyone for joining, and have a great rest of your IETF.